Hello guys, this is 𝗥𝗘𝗙𝗘𝗦 and today we are here for the new video, the 5th of the series, which is about enemies. I think for me this is the best part, but the most difficult to explain for me. So we're gonna go step by step. First, we're just gonna try to make the brown enemies the first one which don't move and just shoot and try to kill us. This is quite a dumb IA, so we're gonna first make it, and in the future video we're gonna upgrade these blueprints, AI, and everything around this enemy. So at the end of this video, you're gonna get these brown enemies who try to shoot us, calculate some bounces to get us, and some default values to make the others enemies. One thing to say, let's get started. Okay, so first, into our game pp folder, go into entities and create a folder enemies. We're gonna create a blueprint class character and let's call it bp tank enemy master. We're gonna do the same as the projectiles. We're gonna make a master bp for all the tank enemies and create some child blueprints from this. We need some default variables. So as you can see, into this website, which is on the description, you can have the tank attributes. Here we can see that tank brown appeared first. He is stationary, have bullet normal, so we already created here like normal and faster. Master is just the name. After that, you have a fire rate cooldown, which is slow or fast. We're gonna have ricochets, which can be 0, max bullets, which can be 1 to 5, and after that we have max mines. You can have no mines or 2 to 4, and behavior, which describe how the AI gonna act into the game. So for the first one, it's just passive, so he don't move, he is stationary. He just shoots normal bullets with normal speed, with a fire rate slow, so it's kind of default fire rate. He just have 1 ricochets and just 1 bullet. So we're gonna make the default variable. Into the tank enemy master, we're gonna first add some default values which is not in this table. So first, we just want to know how many life he have. So because into the wheat tank, we have this functionality that if you get hit, you instant die, but you can make like you need 2 projectiles to die or something else. So we create this because we're gonna do this into a future video. So let's create life and life max with float values and the projectile to shoot. You can just try to go to the player and Ctrl+C, Ctrl+V into here. So we have the projectile. After this, we also need bullet count max, and mine count max. So let's Ctrl+C, Ctrl+V all of these values. After this, remember we had some interfaces to get back the mines. So go into class settings, implements, and search for your bullets count and your mine count. Compile and save. After this, we gonna need some more features. Now we need some enumerator to get some lists you can choose into it. So into the folder, go blueprints and enumeration here. Create this and call it enum, and let's call it like tank type. So it's gonna be the name here into it. Let's create some enum and call it like brown and all of these names. So we have ash, marine, yellow, with a W, pink, green, violet, white, and black. As you can see, you can add some description. I'm gonna explain to you. This is gonna be really useful at the beginning. First, we're gonna add the enum. So let's call it tank type. Here, into the value, search for enum tank type here. As you can see, if I put my mouse above the list, this is gonna give me the description of the overt one. So brown is 𝗥𝗘𝗙𝗘𝗦, ash is 𝗥𝗘𝗙𝗦, and marine is no, because we didn't put them. So we can just here try to make this copy, Ctrl+C, and here Ctrl+V. So now, when we are here, we got some information you have to compile to say. So now we got dimension, stationary, normal, slow, 1, 1, tirade, and passive. So let's do it for all of the tank type. And voila. So now we got all of our description. That's perfect. After this, let's create some more enum. We're gonna need enum movement. We're gonna need enum behavior, and we're gonna need enum precision. Into the behavior, we're gonna add passive, defensive, unconscious, offensive, active, and dynamic. After this, into the movements, we're gonna add normal, stationary, slow, and fast. Let's leave the precision for now. Let's add the values, the enum here, so precision, movement, and behavior. Now we need some meshes here. So we're gonna copy exactly this. Copy the cannon mesh and the muzzle, paste it to the capsule here. After this, go into the mesh, select tank body, put it into the mesh, put -90 into the Z, set her for tank body, compile and save. Here into the muzzle, select again this socket, and for the capsule radius, put 50. And voila, we got our tank. Let's just as you can see, I created a material tank enemy color. Into it, I have a third vector converted to parameter called color. This is gonna be helpful to put some color into the tank to make some difference. So put it into the cannon mesh and the mesh. Here we're gonna add some default functionality for all the tank. So first, let's create this function for the color. Update tank color. Here, let's create a material dynamic instance. Here, let's select the tank enemy color. We don't need to modify this. Here, let's set vector parameter value. The name is color. The value, drag and drop into the function, so it's an input now. Now, let's add a return node with the return value here. Now, let's call the function into it, and here, promote to variable, and set tank color. Now, let's select the mesh and the cannon mesh. Let's set material, and as you can see, we have element 0, so element index 0. Let's put the material as the return value, and here, connect. Don't forget to connect it twice. And now, if we drag and drop, and try to change the color, like it's red, when we play, it's red. To make this appear before the launch, you can go into the construction script and paste it here. So now, when you modify the color, it's modifying directly. Now, but before this, we're gonna have to set the life as the life maximum. So it's like putting the default life. Connect this like this. We don't need actor begin overlap. Now we're gonna need some function. What we want to do is that from a precision percentage, we want to know if he's copying like 50% precision, 75, 99, or 100. It's like kind of example. We can go for 30, 60, 90, and 100. It's gonna be more easier. Doing this gonna be useful if we want that our bot is like scoping like kind of nowhere and try to make shoot with bounces. So we first need that if our tank, this is the enemy, and our tank here, which is player, we want first that if the player is in front of the enemies, this is gonna shoot the projectile. After this, we're gonna want to see if it's like bouncing. So to do this, we will need like a scope trace test function. So let's create it. Scope trace test. Into it, let's put a line trace by channel. Here, let's get our muzzle, get world location, get the forward vector, multiply, add with the world location. Here, convert to float and promote to variable. Let's call it trace distance. Here, let's put like 5000. Put this into the end and put this into the start. Here, let's break the it result. Do a branch, and as we seen into the website, some enemies don't have ricochets, so they don't have bounce. So we need a Boolean variable which say if it can bounce. As default, let's put that true. Drag and drop, put the B, and after the first line trace, let's calculate if it's bouncing. If it's not bouncing, let's put a return node here. Into the return node, let's add a variable and call it should shoot. This is gonna answer our question: is the line trace good to launch a projectile? So if this is not hitting and if we have no bounce, so like this, let's return should not shoot. If it's not hitting something, and want to bounce, let's do nothing because we want to hit something to get the normal, to make the bounce, as we did for the projectiles. Now, let's get the plus, subtract from the get world location here. Now into it, mirror vector by normal, and into the normal, let's put just normal. Hit actor, let's get the equal and put it into a branch, and here search for get player character. Here we want to know if the actor has tag entities. So every entity is gonna be detected into the tag here. Let's click the self roots tag, and to the actor advanced tags, let's add entities. Make sure this is like the same. So copy and paste into here. Go into the tank player, search for tag, and add exactly the same. As you can see, we created a tag called tank. So let's delete the entities. This is gonna be much easier with the tank. Before the bounce, let's check if it's already hitting a tank. If yes, let's put a return node with should shoot. So it's gonna shoot a projectile because we hit a tank. Be sure that ignore self is selected because we don't want to suicide ourselves. Well, let's continue with the ricochets. Here, let's add some add operators. Here, we need the impact point into the first plus, the impact point into the second one. Here, we need the mirror, and here, the default normal. So it's like this. Here, let's call again a mirror vector by normal and swap this. Into the last videos, we put the tank player collision as ignore into the visibility. But as you can see, we want to know with visibility if it's hitting a tank. So be sure that it's block check. Into the capsule components, be sure it's kind of the same damageable and block into the visibility trace. Why we want the visibility trace? It's because we want that the projectile bounce into the wall, so it's detecting the wall with this line trace and detecting the same. Why we want that the visibility trace is blocked into the enemy and the player? It's because that we want with only one line trace to check if it's hitting a wall or an enemy. Here, this is not a mirror vector by normal. We need a find lookat rotation and put it like here. Now, let's get the forward vector 2 times, and we're gonna put the second line trace after the bounce. So here, if it's bouncing, we're gonna do a line trace. But if it's not bouncing and we touch something, this is not actor as tag, so return should not shoot. If we didn't hit a tank, but we have bounce, put a line trace, we're gonna make the bounce. But here, if we don't have bounce and we hit something which is not a tank, we want to say should not shoot. So put it to false. Now let's do the bounce. Let's drag and drop the impact point here. You can press R when you are drag and drop. This is gonna put a dot like this, a reroute node. Here, drag and drop a plus and add a multiply connected from the first forward vector. Here, convert to float and put a default value as 50. This is like gonna be a security, so it's gonna bounce, it's detecting the bounce correctly if it's like hitting a corner. Here, let's put another multiply, convert to floats, and get the trace distance again. let's put the plus into the start and the end, and this one into the end. Into here, let's add a branch, break it result, and do the same if actor has tag. So if it's sitting, is it a tank? If yes, add a return node and say it should shoot. However, or if it's not a tank, don't shoot. If it's hitting nothing, let's should shoot to false too. Now we have our line trace. Let's put as for duration. Now let's explain to you what is happening. So into the eventic, drag and drop the scope trace test like this. Now go into the default and put like tank master. Let's play. And as you can see, this is line tracing. If I go here, selecting the tank and moving the cannon mesh, as you can see, this is trying to make the bounce. So if we wait the line trace disappear, we can see that it's trying to check, no enemies, nothing, hitting something. Is it an enemy or a tank? No, so make the bounce. It's hitting something. Is it a tank? No, so do nothing. But here, as you can see, this is hitting something. So it's green. So it's saying, oh my god, this is a tank. So I should shoot now. So it's not doing the bounce because we don't want the bounce now. If I put like this, as you can see, this is trying to hit. Is it a tank? No, so bounce. And now hitting something. Is it a tank? Yes, so it's green now. Now let's create the shoot function with the condition around it. So first, let's duplicate the can we shoot. Rename it can shoot and the can we mine as can mine. If you have copied the variables, it's gonna be the good names. Let's close this function. Now let's create a custom event and call it shoot. Call the function can shoot. If yes, we're gonna add into the bullet count, so increment integer. After this, spawn an actor from class, which is the projectile to shoot, and into the split truck spin of the transform, let's get the muzzle, get the world transform, split, and put the location and the rotation into it. Here is the max bounce count. So we need to promote to variable because we need, as we seen into the wiki, there is max ricochet, max bounces. So let's put it like this and put the default value as 1. The player ref is literally the shooter ref, so let's put self. Here, let's spawn sound at location, so it's gonna be the same as here. You can like Ctrl+C and Ctrl+V after this, so it's gonna be much easier. Here, you can get the location like this. This is kind of weird to put these lines. It's horrible, but it's okay. Here, into the cannon mesh, make sure that the mesh is correctly selected because sometimes it's like when you copy and paste from another blueprint, this is resetting this. Let's change the color to be more comfortable to see. Let's do gray. And now, into the event graph, let's do the same bullet count. So if it's calling the bullet count from the self-reference player ref, which is not player ref from now, so we can go into the projectile, so projectiles master, and rename it instigator reference. So now this is instigator reference. As you can see, you can get the instigator too, but it's not exactly the same as we created just a character object reference. This is more precise to do like this. As you can see, this is kind of the same, so refresh node and put back this. Go back into the enemy master, and here, as we did like this, let's decrement the integer of the bullet count. So this is the shoot functionality. Now, into the eventic, we're gonna do some special things. We're gonna first put a delay like 0.2. So it's like scope trace test like every 0.2 second. Here, drag and drop a branch, and if it's shooting, let's call the can shoot function. If it's true, we can shoot, so do once, and call the function shoot. Here, let's put a delay and promote to variable and call it fire rate. let's put the default fire rate to like 3. Every 3 seconds, we're gonna reset the do once, so we are able again to shoot. So now we have our shooting dependencies. So let's put like this. As you can see, the ricochet is like this. If I go into the light race, he's shooting because he detected me. If I go out, this is not detecting me. And if I go here, detecting me, so he shot to me. Now let's make the precision functionality. This is gonna be these kind of weird scope movements that the tank do in the game. You're gonna see. Into the event tick, let's put a sequence. Here, let's put another delay, but this time promote to variable and call it precision rate. Let's put like 2 seconds. Every 2 seconds, we want to rotate the tank into the player with a percentage of precision. Let me explain. So, if we have our tank, this is the enemies, and our player here, we want to know if this is 100%, this is gonna scope like this, we're gonna know the right vector of the player and the left vector, and multiply like this to get kinda forward vector randomly between these 2 points. If it's 50% precision, this is gonna scope like this, or every point between these 2 points. If it's 100%, let's draw it as purple, the point gonna be here and here. So it's the collision of the player. So the enemy can only scope into the player. So it's 100%. Let's do the same with the like 60%. This is gonna be here and here, so it can shoot between this yellow range. So we first want to get the right and the left vector, get the end trace location, and after this, get a random point between these 2 points. And then get the forward vector between the enemies into the random point, which is like this for no reason, but like it's an example. So we're gonna rotate the tank toward this pink point, so our enemy gonna be able to scope. So let's do this. Let's create a function and call it precision scope. Remember, we created an enum called precision. Let's put like 0, 1, 2, and 3. Let's call it like it's 30%, 70, 60, 90, and 100%. Into here, we have our precision tab with description. So into here, let's drag and drop the enum. Into the enum, let's call for switch on enum. Let's put like this. Here, let's create a float value, which is called precision offset. This is gonna be set about the percentage. So I find some correct values, like it's 0 for 100%, 100, 200, and 400. This is pretty fine. You can move these values, so it's good for you. Let's connect all these nodes, and after this, we want to set the target lock. So it was the pink point between the two last points from the right and left vector. So let's create a local variable and call it temp target lock. Let's say it's a vector. Let's set it here, and we're gonna make the vector calculation here. So now we want to get first the player character, get the actor location, and get the actor location, but this time for the self. Here, let's find a lookout rotation between these 2 points. Get the right vector and multiply, convert these to floats, and multiply to random floats in range. Here, let's get the precision offset, multiply to -1, and put it into the minimum. Get back the precision offset and put it into the max. So this is gonna be like, if I put 500 just to show you, to -500 to 500. So it gets into the right vector, a forward into the right or into the left, randomly, set it at the beginning from this enum. So now we added. Now we have to add from the get player character, get back the actor location, and add these two values. Put into the 10 target lock, and into the return node, let's drag and drop the result. So this is gonna be the target location. Now into the event graph, let's call it our precision scope and promote to variable and say target location. We want that the cannon mesh gonna rotate towards this target location. This is pretty simple. Let's put set world rotation to the cannon mesh. Here, get the world rotation. Split the truck spin here. And into here, we want to return 2. Let's first add the world delta second and the precision speed as a value. Precision speed. Now, let's make 2 rotator. We want that this is going from the current Z cannon mesh rotation. Let's put it like this. This is gonna be more beautiful. And here, the new rotation. So we first want to get actor location. After this, put it into find look at rotation. This, the target, gonna be the target location. Split strut spin and put the Z into it. So now we have our target find look at rotation. Now into the precision speed, let's put like 2. Now, if we play, the tank gonna try to scope us. As you can see, we missed some things. We have to minus 90 this value. So now he is trying to scope us. Let's make it more visible. Into the scope trace test, first let's put the trace duration to .2. So we can see the detection frame by frame. So now I'm moving. He is trying to scope to me. And when he found a line trace, he shoot to me. As you can see, if I go here, he can bounce to me. But as the brown enemy, this is kinda randomly shooting. So we got the result we wanted. We can try something. Go into it, create a child blueprint, call it BP tank brown, go into the tank brown. Into the tank brown, let's put a color kinda brown, like this. Let's put the values of the wiki. So he have only 1 bullet, he have no mine, he is brown, he have no precision, he is stationary, passive, brown color, trace distance, you don't touch, bounce, yes, it's bouncing only 1 time, with a fire rate really slow, so 3 is kinda good, a precision rate of 2, this is like you prefer, precision offset, you don't touch, target location, you don't touch, and precision speed gonna be the smooth rotation of the cannon mesh of the enemy. So if it's 0, it's gonna TP. If it's like 2, this is gonna rotate slowly. And if it's like 50 or 100, it's gonna TP again. So increase the precision speed if you want to increase the speed of the rotation of the cannon mesh. Now let's just try something. Let's put the take brown like here and put into the enemy master, into the precision scope. Let's add into the event graph. Here, let's draw debug sphere. Here, let's put the center. Let's put a radius of 25, a duration of 1, and a thickness of like 10. This gonna put a little ball where he have to scope. As you can see, he is trying to scope because he is 50% between the player. Sometimes it can be really precise because it's random. So now into the tank brown, if we put into the class default a precision of 3, that is 100%, he gonna always scope 100% to me. But as you can see, 100% is not that good because he is not moving. So that's why the precision is kind of specific for some enemies. This is kind of moving enemies, trying to find some good ways to shoot us. So the brown have to be really 50 or 30 precision. So into the deck brown, let's put the precision back to 0. So now this is gonna gets a random point between these two. And voila, we got our tank. He is trying to scope me, and when he arrives to find a line trace shooting me, he is literally shooting to me. But as you can see, if I shoot to him, this is not hitting him. So go into the tank enemy master, add a value tank any damage, and let's first just print the damage he take. So into the projectile master, we want to add a apply damage system. So remembered, we have a line trace with the damageable detection. Here, into the event tick, let's put a sequence and add something, the function test trace damageable. Here, if it's hitting something, let's break the hit result and say if the actor has tag tank. So first we want to know if it's difference of the instigator ref. So if it's true, we can go after. Here, now let's search if it's a tank. Make sure if exactly the same name. Let's put a branch. And so, yes, this is difference of the instigator. Search now if it's a tank. If it's a tank, you want to apply damage to this actor. Here, promote to variable and call it base damage. You can expose and spawn this value. So now, into the normal, into base damage, let's put 100, into the fast 102, compile, and now we are doing the applying damage. So now, if we try it, as you can see, this is writing 100. Into the trace damage, as you can see, we have original forward. So into the return node, remove this. We don't need it. As you can see, this is writing the damage really often, like this. We don't want that. If the projectile is hitting something, this is destroying herself. So now, if this is hitting something, this is exploding and destroying herself. Now, into the tank master, let's make the die functionality. Here, let's delete the print. Let's set the life and calculate the life is minus damage. But first, we want to know if the life is not even already at 0. If it's greater than 0, let's set the life minus damage value. Let's put like this. Because if it's false, it's because life is less or equal to 0. So put like this. And after this, we want to check again if the life is less than 0, we want to destroy actor. Here, into the projectile functionality, let's put a isValid to make sure that it's calling the instigator ref only if it's visible, valid. Because now we destroy the enemy when we shoot at him. So let's try it. Now, if I shoot, we made a mistake. Here, be sure it's less or equal to 0, because in my case, I put it like base damage default as 100, but the enemy's life is to 100. So it's stopped to 0, so it's not less, so it don't destroy. So now, if we try, we can shoot to enemy, and this is disappearing. For now, let's not do the same for the tank player, because we're gonna make it with the victory and defeat functionality into future video. And voila, we got this result, guys. The tank is trying to scope me with a percentage of precision. If he finds a way to shoot me, it just shoots to me. As you can see, this is writing the damage in the top left. And if I shoot to him, paf, this is destroying the enemy. So let's add a little feature now before destroying. Let's spawn a system at location, and let's use the exactly same mine explosion here. Get the mesh world location, put it here, and now if I try to go explode the tank, this is exploding. So voila, guys, we are finished with this tutorial. I hope you enjoyed this tutorial. Sorry for this week, I was kinda think. I think you can hear this in my voice. I'm like not giving attention to my accent, so that's why my French accent is coming back. But be sure I'm gonna be back and for more tutorials. So thank you guys for following this video. Don't forget to like, subscribe, activate the notification, comment if you have any question or suggestion or kind of tips. And it was a pleasure. It was 𝗥𝗘𝗙𝗘𝗦. See you next time for a new video. Bye bye.